What's up? What's up? It is your man, Jimmy Chan. All right, LabWork 8. Let's get it started. So, first question says to divide 15 x to the 9th minus 40 x to the 8th minus 40 x to the 6th plus 25 x to the 4th by 5x to the 6th. All right, so what we're dividing by is a monomial. So this is a polynomial divided by a monomial. Okay, so this part right here is a different process than if I was dividing by a binomial. Okay, so essentially we're going in reverse with adding, subtracting fractions. Okay, so I'm going to call this split the denominator. Okay, meaning I'm going to write out a bunch of different fractions here. So I got 15x to the 9th over 5x to the 6th minus 40x to the 8th over 5x to the 6th minus 40x to the 6th over 5x to the 6th plus 25x to the 4th over 5x to the 6th. Okay, so I'm splitting the denominator. So essentially, when I'm adding, subtracting fractions, right, I need common denominators. So what we typically do is add or subtract the top and keep the bottom. So this would be the same idea. If I go and add these fractions together, I'll get that original back, my question back again. So don't go in that direction. Keep on going. So now you're going to reduce each fraction individually. Okay, so I guess, you know what? I guess I'll call this step 1. And step 2 would be not reduce each fraction. Okay, so I'm just going to look at this right here. I'm going to reduce this fraction right here. 5 and 15 going to reduce, right? And then there's 9x's on top, 6x in the bottom, 6 will cancel out. There'll be 3 left on top. So we're bringing back the rules of exponents, right? So this first one is going to become a 3x to the 3rd, right? So 15 divided by 5 is a 3. And then, like I said, there's 9x's on top, 6x on the bottom. And we reduce, 6 of them would go away, leaving you 3 left on top. Minus 40 divided by 5 is going to be an 8. 8x's on top, 6x's on the bottom. I'm left with an x squared. Minus 40 divided by 5 is an 8. I got 6x on the top, 6x on the bottom. They all go away, and that part's done. So now I got the last one left. I have 25 divided by 5, which is going to be a 5. 4x is on top, 6x on the bottom. 4 of them go away, and I have a result is that I have an x squared on the bottom. So that would be my answer right there. So if I was to do this, I would just do it this way. There we go. So that would be my answer, and that is going to be choice C. There we go. go. All right, on to number 2. Okay, number 2. This is a little bit different. So this one says take 16x to the third plus 12x squared minus 24x plus 14 and divide that by 4x minus 1. Okay? So what this would be, like if I was to rewrite this as a regular fraction, this would look something like this. You know what? Yeah, let's just leave it that way. So now notice that my denominator that I'm dividing by is a binomial. So this would be called a polynomial divided by a binomial. Okay, so this one here has a different process also. This one is what we're going to use what they call a long division. Okay, now there is another method, and if you want to use that method, you're welcome to, but I'm not going to teach it because there's a lot of different criteria that need to be met for you to do that. So I'd rather not have to teach it that way. Again, it becomes more things to remember, where with long division is a little bit easier. So like, let's say for example, I was dividing, I don't know, 33 divided by, let's say 3,620 3. There we go. And I'm going to divide this by 3. Okay. So back in the day when you guys did this, actually, yeah, you know what? Let's use 5. Okay. So back in the day when you did this, what you do is you ask yourself, and back in the day meaning like back in 4th grade probably for you guys, you ask, how many times does 5 go into 36, right? And you'll say, well, that would be 7 times, right? So first thing you did was ask yourself how many times did it go. Then the second step, you would then multiply the 7 times 5 and get 35. Then you would subtract, okay? Which is the same thing as saying, if I took the positive 35 and flipped the sign of 35, now become negative 35, I'm adding, and I get 1. Then the last step is that I brought the 2 down. So now I have 12, okay? So again, what were the steps? I'm going to repeat the steps right now. So it's always the same 4 steps over and over. So the next question is now saying, how many times does 5 go into 12? That's step 1. And that is going to be a 2. Second step, we multiply. 5 times 2 gives me 10. Step 3, we flip the sign and we add. So we get 2 left, right? So that's step number 3. Step number 4, we bring down the next digit and get 3. So let's repeat those 4 steps again. So step 1, how many times does 5 go into 23? Actually, let me do it this way. So how many times does 5 go into 23? And you're going to say 4 times. So that's step 1. How many times does 5 go into 23? Second step is to multiply 5 times 4, which is 20. Step 3, flip the sign and add. Flip the sign and add. And so we got 3. And the fourth step is to bring the next digit down. And when we run out of digits to bring down, back in the day, you guys would say, well, we have a remainder of 3. Well, that actually doesn't make any sense whatsoever. So what we actually do is saying, okay, so since we don't have any more digits to bring down, so we're going to now say it's going to be 724 plus 3 over 5. Yes, the 5 came from here, and that 3 came from down here. Okay, so that would be how long division works. It's the same 4 steps over and over and over again. Okay, so we're going to apply the same 4 steps here. Okay, so the first thing we're going to do is say, okay, so I'm going to have a 4x minus 1 divided by, that's not going to give me anything nice, so boom, there we go, divided by 16x to the third plus 12x squared minus 24x plus 14. All right, so now the difference between that 5 that I divided by is that I'm only going to deal with just that first term in both the numerator and denominator. Okay, so I'm only going to ask myself, how many times does this first term, 4x, go into the 16x cubed, right? So my step 1 is going, how many times does 4x go into 16x cubed? So you guys can actually do the work right here, going 16x to the third divided by 4x. And what you'll get is a 4x squared. So that's when you go, okay, I'm going to put down 4x squared. Right? So that's first step. Second step would be to multiply. Okay, so I'm going to take that 4x squared. So this is step 2. I want to take that 4x squared that I just found in step 1. And I want to multiply that to that 4x minus 1, which is this whole thing right here. Okay, so which means I got to distribute. So what do I get? I'm going to get a 16x to the third, minus 4x squared. So that is going to go right here, 16x to the third minus 4x squared. Okay, so now what I'm going to do is so step 3 is flip the signs and add. Okay, so let's go ahead and flip the sign. So positive 16x to the third now becomes a negative 16x to the third. The negative 4x squared now becomes a positive 4x squared. Okay, so now I'm going to add 16x to the third minus 16x to the third goes to 0. I got 12x squared plus a 4x squared, so I get a 16x squared. And then step 4, actually, you know what I should do? Because this was in purple, so let me put that in purple. And then the last step is to bring down the next term. There we go. So then I want to bring this next term down. Bring down this next term. Bring down this next term. There we go. All right. So that's going to be minus 24x. Okay? So those are my 4 steps. So now repeat. Okay? So step 1 was how many times of 4x, notice I put 2 lines there, go into the 16x squared, just the first terms. So I'm going to take 16x squared and divide it by the 4x squared. Well, that's going to give me a 4. Ooh, sorry. Whoa, 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 whoa. What am I doing? It's that 4x. Because that's what the first term is. So 16x squared divided by the 4x. Okay? So that's going to give me a 4x. Right? So it's a positive 4x. So I'm going to put down plus 4x. Step 2, I'm going to take that 4x and multiply by the 4x minus 1. And I'm going to get a 16x squared minus 4x. So I'm going to bring it up back up here. 16x squared minus 4x. Okay. Then I'm going to flip the signs. Then I'm going to add. And when I add, the 16x squared minus 16x squared goes to 0. Negative 24x plus a 4x gives me a negative 20x. And then the fourth step is, wow. There we go. Bring down the next term, which is plus 14. Okay? So I repeat those same 4 steps again. All right? So step 1 was what? How many times does 4x go into negative 20x? Notice how I have now 3 red lines with the 3 red lines. So negative 20x divided by that 4x. I get a negative 5. So I'm going to put negative 5 right here, minus 5. And then I want to take that negative 5 and multiply by that 4x minus 1. And I'm going to get a negative 20x plus 5, right? Because I got to distribute that negative 5. So I'm going to write up here negative 20x plus 5. Then I'm going to, step 3 is flip the signs and add. So flip, flip. Now I'm going to add. So negative 20x, positive 20x goes to 0. 14 minus a 5 gives me a 9. And step 4 is to bring the next term down. But since there's no next term, that means I'm done. So before I do that, let me do some management here. Management here is for this sake right here. Push this over about right there. Okay, awesome. All right, so what do I have left? What I have left is now, because I got nothing else to bring down, I have a remainder of 9. This will be, and it's positive 9, it's going to be plus 9 over the 4x minus 1. Okay, so that would be my answer. So my answer now is that whole thing, which is 4x squared plus 4x minus 5 plus 9 over 4x minus 1. So that would be my whole answer. And that choice, is going to be choice D. And yes, it does take quite a bit of paper, okay, which is A-OK. All right, so Now, do I expect you to do all of this work on the right side? Not really, okay? The only reason why I show that work is because I found it in the past that when students use those steps, it actually helps them keep things organized, because it's with everything going on, it's tough to multiply, from here to here and then coming into that, or I should say coming into this, okay? So it's a little bit harder to see, right? Now, some of you guys are able to do that, but not everybody can. So that's the reason why I show the work on the side, is because that actually helps a lot of people keep things straight, okay? All right. I'm going to go ahead and start 3 on the next page, because I'm not sure if I'm going to be able to do it in that remaining spot there. Okay, so number 3. Number 3 is asking you to divide x to the 4th plus 1296 by x minus 6. Okay, so here is the biggest thing that you have to make sure that you do when you write this out. So if I put down x minus 6 here, I want to make sure that I have placeholders. What do you mean by placeholders? I want, since the highest power is x to the 4th, I want something to take the spot of x to the 3rd, something to take the spot of x squared, something to take the spot of x. All right, so I want from the highest power all the way to the number, decreasing the power by 1. And those placeholders, I can't call them 1x to the 3rd or 1x squared or 1x. I gotta call them 0. So here we go. So I got x to the 4th plus 0 x to the 3rd plus 0 x squared plus 0 x plus 1296. So notice how those keep on going down in power, okay? Do this really quick. Boom. And then take this and move it as far over to the left as possible. All right. So I'm going to show the same work, right? So how many times does x go into x to the 4th? So I go over here. I say, okay, I got x to the 4th divided by x, and I get x to the 3rd. So I write down x to the 3rd. All right. So then I got to multiply. So I'm going to take the x to the 3rd and multiply with x minus 6. And what I'm going to get here is x to the 4th minus 6x to the 3rd. All right. So x to the 4th minus 6x to the 3rd. Then I'm going to flip the signs and add x to the 4th minus x to the 4th, 0. 0x to the 3rd plus 6x to the 3rd is going to give me a 6x to the 3rd. Next step, bring the next term down. Which is plus 0x squared. Okay? Then I'm going to say the same thing. How many times does x go into 6x to the 3rd? So you're going to say, okay, 6x to the 3rd divided by x gives me a 6x squared. Okay, so plus 6x squared. Then I have to multiply. 6x squared times x minus 6. Well, that's going to equal to 6x to the 3rd minus 36x squared. All right, so 6x to the 3rd minus 36x squared. Okay, then I have, that was the second step. So the third step is to flip the signs, right? So what do I get? I get positive 6x to the third minus 6x to the third, that goes to 0. 0 plus 36x squared is going to give me a 36x squared. Then, look at that. That one actually works. So I want to bring down the plus 0x. Then I ask myself again, how many times is x going to 36x squared? So over here, 36x squared divided by x gives me a 36x. Okay, so plus 36x. Okay, now I got to multiply. So 36x times x minus 6 is going to give me a really big number. It's going to equal to 36x squared minus 216x. Okay, so let's write that down. 36x squared minus 216x. Okay, so now flip the signs and add. So I'm going to be left with 216x, and then I have to bring down the next one. There we go. So plus 1296. Okay. All right. So again, how many times does x go into 216x? So we'll go 216x divided by x gives me 216. All right. So now plus 216. Now I got to take 216 and multiply by the x minus 6. And I'm going to get a 216x minus a 1296. So write that down. 216x minus 1296. Now here is where people kind of get excited, but for the wrong reason. Okay, I haven't flipped the sign yet, and you guys are looking at the 1296 in the green and the blue, and you're like, ooh, that's going to cancel out and it's going to come out even. It's actually not true. Look at this. When I flip the sign, what happens? That becomes negative, and this negative 1296 becomes a plus, right? So the result now is going to be a 2592 is what's left, right? So you got to be careful with that. So now we bring that up to be plus 2592 over x minus 6. So that would be my answer. All right, so now I got to try to remember all of that. So the answer is x to the third plus 6x squared plus 36x plus 216 plus 2592 over x minus 6. And that's going to be choice A. Go. One. And here we go. So that's problem number 3. All right, on to problem number 4. All right, so problem number 4 sounds confusing, but it really isn't. Okay, so it's problem number 4. So it tells you that p of x is equal to 3x squared minus 5x plus 4, and then it gives you this negative 2. Okay, so it says for the given polynomial p of x and the given c, use the remainder theorem to find p of c. Meaning, what I'm looking for is the p of negative 2. So I'm just going to do 3 times negative 2 squared minus 5 times negative 2 plus 4. okay? So when I do that, I get 3 times 4 plus 10 plus 4. So I get 12 plus 10 plus 4. So P of negative 2 is going to equal to a 26, which is choice C. And there we go. Okay, so number 5. All right, number 5. Oh, look at that. We have rational equations. So we have a 1 plus a 1 over x equals to 12 over x squared. All right. So, in order to get rid of the fractions, what do we need to do? We need to get them all to have the same denominator so we can get rid of all of them. This is an equation, okay? So what I'm going to do now is going to take this and duplicate it. And we'll slide it down here. But make some moves here. And we'll move these over just a little bit. Okay, and we'll put this over 1. So I'm going to say, what do they have that I don't have, right? So what's missing? So what's missing here is an x squared. So I need to multiply top and bottom by x squared. What's missing in the middle one is an x. So I'll multiply top and bottom by x. And what's missing on the last one is nothing. Okay? So again, if I look at this way, for what I did before, right? You know what? Let me do it this way. Let me re-explain all of this here. Why I chose those things here. So if I look at just the denominator, I have a 1 here, an x here, and x squared here. So when I say what do they have that I don't have? Well, this is missing the 2 x's, right? This one is missing, let's say a 1 and an x, right? And this one is missing a 1. So now if I look at each of the denominator here with what's missing, all three of them has a 1x times x. 1 times x times x, 1 times x times x, right? So the red is what I have missing, so that's why this is multiplied by x squared on top and bottom. This is multiplied by x on top and bottom, and this is multiplied by 1 top and bottom, okay? So what do I get based on that? What I get then is going to be a x squared over x squared plus x over x squared is equal to 12 over x squared. Okay? Now notice that my denominators now are all the same. Since the denominators are all the same, that means the top are all the same. So now what we can do is say, okay, now I can write the equation x squared plus x is equal to 12. I know how to solve that. I see an x squared and an equal sign. What does that mean? It means a quadratic equation, which means I gotta get everything on one side. So that means I gotta do x squared plus x minus 12 is equal to 0. And I got to factor the non-zero side. And you might have to use the AC method here. But it's x plus 4, x minus 3. And that's going to equal to 0. Then I have to set each factor equal to 0. So I got x equals negative 4 and x equals 3. Okay, so now notice that I said x equals negative 4, x equals 3. So one of the things I do need to do is look at this and saying if I put in the negative 4 here, well, in here for x, would I have an undefined fraction? And if I put a negative 4 here, would it become an undefined fraction? Okay, which it would not, and then I got to do the same thing with the 3. If I put a 3 in here, would this fraction become undefined? The answer is no. If I put a 3 in here, would that make that undefined? And the answer is no as well. So since that is the case, then I know that my x is going to be negative 4 or 3. Okay? And that is going to be choice C. There we go. All right, that's 5. On to number 6. All right, number 6. Number 6. Okay, so again, 35 over x is equal to 6 minus 1 over x. Okay? So same thing. I got fractions and an equation. So I'm going to go ahead and bring this down. Make a little bit moves here. Move this over just a little bit. Move this just over a little bit. And move this up a little bit. Because I want to put this over 1. Alright, so what do they have? They have x, a 1, and an x. So I ask, what do they have that I don't have? Well, this one doesn't have a 1, this one doesn't have an x, and this one doesn't have a 1. So when I look at all these denominators, they both have, all of them have 1 times x. Okay? Alright, so that means what I got to do is multiply this by 1, multiply this by x on top and bottom, and multiply this by 1 on top and bottom. So what do I have? Then I have a 35 over x is equal to 6x over x minus 1 over x. All right. So again, my denominator is all the same. Right? Perfect. So that means I can write the equation of 35 is equal to 6x minus 1. Well, okay, we're good. So now I gotta solve for x. So what do I have to do? I have to add the 1 to the other side. So I'm going to have a 36 is equal to 6x. Divide the 6, so x is going to equal to 6. And again, I would look at this right here. If I put a 6 in for x here, would it make this fraction undefined? No. Put a 6 here, would it make that undefined? No. So therefore, that is my answer, and that is going to be choice C. There we go. Excellent. So on to number 7. Okay, 7. I have to turn the page. All right, 7. A little bit more difficult, but not too shabby. So this one is going to be 1 over a x plus 7 plus a 4 over x plus 5 is equal to negative 2 over a x squared plus 12x plus 35. Okay, so number 1, make sure that anytime you see parentheses, put parentheses around them. Okay, so that's number 1. Number 2, I would still do this problem exactly the same way as I just did the rest of the problems. Okay, so I'm just going to take this over, slide this over a little bit, slide this over a little bit. Okay, so however, you do want to make sure that you factor everything, okay? So I need to make sure I factor this right here, okay? And when I factor this, it's going to become x plus 5 and x plus 7. So again, I would ask the same thing. What do they have that I don't have? Well, this one needs an x plus 5. Well, if I do it to the bottom, I have to do it to the top. This one, the one in the middle, is missing x plus 7. If I do it to the bottom, I have to do it to the top. And the last one has both the x plus 5 and the x plus 7. So if you look at all three denominators here, you'll see that all three of them has an x plus 5 and an x plus 7. Okay? And everything in the parentheses is just a number. Okay? So, what do I have now? I now have, I just keep on going vertical. So now I have x plus 5 over x plus 5, x plus 7, plus I have 4 times x plus 7 over x plus 5, x plus 7 is equal to negative 2 over x plus 5, x plus 7. So if you notice, my denominator is the same here and here and here, right? So that means I can write the equation x plus 5 plus 4 times x plus 7 is equal to negative 2. Because if the bottoms are all the same, that means the top must be the same. So now I finish by doing, I got to distribute the 4. So I got x plus 5 plus 4x plus 28 is equal to negative 2. I want to combine like terms. So on the left side, I'm going to have a 5x plus a 33 is equal to negative 2. Subtract the 33 over, 5x is equal to a negative 35. So x is going to equal to negative 7. Okay, so same thing. Before I say that this is the answer, I got to put this all the way up here. Okay, so actually all the way up here. So if I put a negative 7 here for x, I get negative 7 plus 5. That's a negative 2. So that denominator won't be undefined. So that's okay. But if I put negative 7 here for the x, what do I get? I got negative 7 plus 7, which is a 0. So anything divided by 0 is going to be undefined. So therefore, that fraction is undefined. See what I'm doing? All right. So if that's the case, that means that x minus 7 cannot be an answer, and this will have to be rejected because it will create an undefined fraction from the original. So therefore, since that's the only answer I have to compare it to, my final answer would then say no solution, and that would be choice B. There we go. All right, so that was 7. On to number 8. Okay, 8, same idea. All right, so I got x plus 5, put parentheses around it, over x squared plus 3x minus 4 minus a 5 over x squared minus 2x plus 1 is equal to x minus 5 all over x squared plus 3x minus 4. Okay, so again, I have to factor all the bottoms, right? You definitely do not want to multiply that x squared plus 3x minus 4 and multiply that with the x squared minus 2x plus 1. You definitely do not want to do that, okay? So, because then you're going to have x to the fourth, which is going to just get really, really, really ugly. So my suggestion is to factor all of them. So what I would have is the x plus 5 over, actually, you know what I'm going to do? I'm going to do it this way. I'll bring it down here. So what I'm going to do is just erase this. Okay, so the bottom here is going to be a x plus 4, x minus 1. This one here is going to be a x plus, x minus 1 times x minus 1. And the last one here is going to be x plus 4, x minus 1 again, okay? All right, so with that being said, what do they have that I don't have, okay? So let me do a little movement here. I'm going to slide this over a little bit just so I can have some room. And I'm going to take this here and slide it over a little bit more just so I have some room. Excellent. All right, so what do they have that I don't have? Well, the one in the middle has 2 of them, of the x minus 1s, and the ones to the sides only have 1 of them, right? So this one needs another x minus 1. Well, if I do it to the bottom, I have to do it to the top, okay? And then the one in the middle is missing an x plus 4. If you do it to the bottom, you got to do it to the top. And the last one is missing an x minus 1. If you do it to the bottom, you have to do it to the top. There we go. Now again, if you look at the denominator, do they all have an x plus 4, x minus 1, x minus 1? And the answer is yes, they do. X plus 4, x minus 1, x minus 1. Awesome. So what I actually have is, and this is a huge recommendation of actually writing the whole thing down. And there's a reason for it. And mainly it's because that subtraction sign. So I have a x plus 5 times a x minus 1 minus a 5 times a x plus 4 is equal to x minus 5 times a x minus 1. Oh boy, I just got done factoring and now I have to FOIL or double distribute or just distribute again. Oh gosh. All right, so let's go ahead and dive into it. All right, so when I FOIL or double distribute the first one, I'm going to get an x squared minus x plus 5x minus 5. Now, the reason why I want you to rewrite this, and whoever makes a mistake, here's where your mistake is. Now, notice that after I rewrote it, I can see that I had to distribute that negative 5. Okay, where up here, you might forget about that negative because it's so far away. You might forget about it and only distribute the 5 and not do anything with that negative. So that is where your mistake will come from. So this middle one is going to be a negative 5x minus 20 is equal to x squared minus x minus 5x plus 5. And there you go. Okay. So let's combine like terms. All right. Wow, so many like terms. Gets crazy. Okay. So I have my x, an x, and an x here, right? On this side. All right. And then I have the negative 5 and then negative 20. And on the other side, I have just that x and that x. But that's on the other side. Okay, so on the left side, I'm going to have an x squared minus x, right? Because positive 5x minus 5x is 0. And then minus x is left. Minus 25 is equal to x squared minus 6x plus 5. Okay, so now we see the x squared, we see the we see the equal sign, so we're thinking quadratics. But what happens? Look at this. When I start to move the x squared, right? When I subtract the x squared, what happens? Well, they both drop out. X squared goes away, right? So let's go ahead and show that. So I'm left with just a negative x minus 25 is equal to negative 6x plus 5. Well, I know how to solve that. That's not quadratic. That's much easier, right? That means I got to get all the x's to one side. So I'm going to add the 6x over to the left, and I'm going to have a 5x. I'm going to add 25 over to the right side. I'm going to get a 30. So therefore, x is equal to 6. Now, here's the hard part. So I'm not going to really hammer on you guys in terms of writing down restrictions, because the answer is what's going to matter, right? Just like the last problem. But if I put in a 6 in for x here, that won't make it 0. 6 in here won't make it a 0. 6 into here won't make it a 0, right? So therefore, I'm okay. And since the other two denominators are the same, I'm good. So therefore, that would be my answer. And that is going to be choice. Nope. I need to go to the next page. There it is. And the answer is A. There we go. All right. Excellent. All right. So that is 8. So on to number 9. Okay, number 9. A painter can finish painting a house in 4 hours. Her assistant, 6 hours. With the same job. How long would it take them to complete the job if they worked together? Okay, so a painter can finish in 4 hours. So the equation that we want to write is that means in an hour they can finish a fourth of the house. Okay, and they're working together with someone that can finish the job in 6 hours. So this person, their assistant, can paint 1/6 of the house in an hour. So the question is, how long would it take if they were working together, right? So that would be the setup that would have to be. But same thing, right? If it's 4 hours, it's 1/4. If it's 6 hours, 1/6. Since they're working together, is an addition. So that means working together, and then the x is the unknown amount of time. So, same idea. We're got an equation here with fractions. So, right? So, the 4 is a 2 times 2. The 6 is a 2 times 3. And the x is just x. All right? So what do they have that I don't have? Well, I don't have a 3 nor an x. The one in the middle needs a 2 and an x. And the last one needs a 2, and a 3. Okay? So if I look at these fractions here, I have a 2, 2, 3x. 2, 2, 3x. And a 2, 2, 3x. So I do have everything covered. Perfect. So that means I got to multiply this one by a 3x on top and bottom. I got to multiply this by a 2x on top and bottom. And I got to multiply this by a 12 on top and bottom. Because 2 times 2 times 3 is 12. So what equation do I get? So what equation do I get? There we go. All right. So I'm going to get a 3x over a 12x plus 2x over over 8. A 12x is equal to 12 over a 12x. Okay. That means this one needs to come down to there. Perfect. All right. So since the denominators are all the same, that means my equation is going to be a 3x plus 2x equals 12. So I got 5x equals 12. So x is going to equal to 12 over 5. Okay, so it's going to take him 12 over 5 hours. But you're like, but that is not a choice. You're right, it is not a choice. However, how do I convert a improper fraction to a mixed fraction? Well, how many times does 5 go into 12? 2 times, right? How many would be left, right? So that'd be 10. 12 minus 10 would be a 2 left. So it'd be 2 and 2/5 hours, right? So that is going to be choice B. There we go. All right. So 10. I think we can fit this in here. 10. So it has the equation of I is equal to N E over N R plus big R. And it wants you to solve for lowercase n. Okay, so let's do this. There we go. All right, so that is what we want. All right, so let me see here. Let me copy this whole thing, duplicate it, bring it down. Okay, so this is what we would typically do. Well, this is what I would typically do. I would multiply both sides by NR plus big R. And the reason why I want to do that is to get rid of that denominator. Okay? I guess you know what you could also think about doing? Think of it this way. How about if I do it even this way? Put this over 1, right? And saying, what do they have that I don't have? And since there should be a parentheses over that anyways, right? So that means the one on the left doesn't have, let's see if it does. Nope. Doesn't have this piece right here. Shoot. Didn't move this far enough over. There we go. So this one doesn't have this piece here. So whatever we do to the top, you got to do to the bottom. And the one on the right has it already, right? So now I have I times this over this is equal to that. Right? So that's what I would have. So since the denominator is the same, I can just write the numerator. Okay, so I gotta try to get n by itself. So in other words, I want to get n isolated. How can I go ahead and do that? Well, let's go ahead and distribute the I through. Okay, so I'm gonna have I n. Actually, let me reorganize this. I R n, right? Plus IR is equal to, you know what? I'm going to reorganize this one to EN, okay? And the reason why I'm doing it is because, let's say, if I was solving for X, typically we write the X in the very back. So that's the reason why I'm writing that, okay? All right, so if that is the case, now I can start moving things around a little bit, right? I have two terms that has N in it and one term that does not, right? So let's go ahead and subtract this IRN to both sides. Subtract IRN to both sides. Okay, what do I get? I get IR equaling to EN minus IRN, right? Okay, so, rewrite this piece right here, up here. Okay, now, am I right by saying that on the right, I can pull a GCF of N out? So the left is still the same, IR. The right side, I can pull an N out, and I would have left the E minus IR, right? So then I can divide it off. So now I have N is equal to IR over E minus IR. And there you go. All right, so that is going to be choice A. And of course, some of you guys are going to be confused about it, but here's the bottom line. How about if I put it this way? Let's say that N was just an N, okay? And I was going to ask you to solve for this instead. Let's put in some numbers, right? 7 is equal to 3N over 2N plus 5, right? So the question is, how would I solve for that? Now, if you were to work on just this one right here, exactly the same steps that you would use for this problem right here is exactly what the same steps that you would use for just all letters. Is exactly the same. There's really no difference whatsoever. So again, all the variables, as you guys call them, letters, are all just numbers. We just don't know what the values of them are. Okay, so if you got to throw in numbers in there just to see where you go and then plug those letters back in, feel free to do that. It's A-okay. So that's what I'm going to try to tell you guys to do, at least think of it that way. All right, so hopefully you guys know. If you have any questions, please let me know. See ya. Bye.